Hey everyone, hello and welcome to Second Saturday. Super excited to be here with all of you on this beautiful day. Today we're going to be exploring outer space with some special guests. We're going to start things off with a really fun story time with Miss Maria. Then we're going to take a trip to a little village to learn how to make a solar oven from Miss Jessica. And then we're going to learn about some great space themed books by Mrs. Liv. But first, I wanted to check in with my good buddy Lori. She's going to talk a little bit about the Summer Learning Challenge, which is starting later this month on June 28th. So I'm going to bring up Lori. Hi,
Hello.
Lori. Hey, how's it
Hi.
going?
Pretty good. So I guess for this space themed second Saturday, we're going to start here on Earth. And I'm just going to share a little information about the Summer Learning Challenge. So like you said, the Summer Learning Challenge starts on June 28th and it goes all the way through August 22nd. And this is a free program for kids all around Chicago. So this happens at all of our branches that are open. Um, and the Summer Learning Challenge has programs, books, grab and go kits, tons of activities. And this summer, everything is all about art. It's about exploring art around Chicago. It's about making art. It's about using art to share your ideas and share what you think about things, um, and and just have some fun and make something new. So here I want to show you a few special things about the Summer Learning Challenge. When you sign up for the Summer Learning Challenge, you get this really nice activity book, and we have one for school-age kids. We have one for little kids too, and so parents can use those with their kids. And this is full of activities you could do with your family, you could do on your own. And you see we have some art highlighted around Chicago. This is a cool mural that's on a building in Pilsen. And also you could win prizes like books when you sign up. At the end, when you finish all your reading, you get a prize bag. And this is how you take part. You go to your neighborhood branch and you let them know you want to sign up. And you could talk to your librarian and you could sign up for the program. And over the summer, you will read 500 minutes. So try to read 20 minutes a day. You read 500 minutes at least over the summer, and you do 5 activities. It could be things like doing a program, like you all are doing right now at Second Saturday, or going to a museum, or creating some art. Whatever you like to do, you choose. And you could talk to your local library about what's going on. And you could pick up some grab and go kits full of art activities, whatever you choose to do. And that's how you do it. And you come back to the branch and you share what you've done, and you bring in your log where you keep track of all that you're doing. Right there. And it's a fun way to keep your brain working over the summer, keep you reading, keep doing fun activities. And we love the Summer Learning Challenge. At Chicago Public Library, we are all about having fun during the summer. So make sure you visit us all summer long and find out all the fun things you can do and explore some art. That's it for me. Hope to see you all this summer right here on Earth, but it seems like the rest of the morning we're going to be exploring more broadly. So have fun on your adventures today.
Awesome. Thanks, Lori.
Yeah.
See ya. Okay, we can't wait to start with art this summer. Remember, it's June 28th to August 22nd. And then later today at 11:30, over on Zoom, we will be joined by a local astronomer and space ambassador, Joe Guzman, who's going to give us a tour of the solar system. So if you weren't able to register for that program, no worries. We're going to record the Zoom program and post it up on our YouTube channel a little later. But before we do that, I want to bring in Maria from the Thomas Hughes Children's Library. She's going to read us a couple stories about space. Hi, Maria.
Hi, Aldo. Thank you so much. Hi, everyone. As Aldo said, I'm Ms. Maria, and I work at the Harold Washington Library Center in the Thomas Hughes Children's Library. I'm so excited to share stories about space with you today. But before I share the first stories, I thought we would share some jokes. And I got these jokes from the book Space Jokes, compiled by Pam Rosenberg, illustrated by Myrnie Gallagher Cole. And it's filled with some really fun jokes, including, why do astronauts enjoy space travel? Because It's out of this world. And I'll share one more. This one is what do you call a spaceship with a broken air conditioner? A frying saucer. Aren't those great jokes? You can get tons more there. And I'm going to share a few more throughout the story time. But now I'm ready for my first book. This is brought to you by, with permission from Chronicle Books. It's Interstellar Cinderella, written by Deborah Underwood, illustrated by Meg Hunt. And it's a little bit different Cinderella story than you might be used to. Here we go. Interstellar Cinderella. Once upon a planetoid, amid her books and sprockets, a girl named Cinderella dreamed of fixing fancy rockets. She fixed the robot dishwashers and Zoom rooms in her care, but late each night she snuck away to study ship repair. One day her wicked stepsisters came dashing in excited. The Prince's Royal Space Parade, our family's invited. I wish that you could come, my dear, alas no room, although, why don't you fix that broken ship and fly it to the show? My toolbox, Cinderella cried, we're stranded here, I guess. But Murgatroyd the mouse sent out a cosmic SOS. I'm here, your fairy guide robot. I'll make you brand new tools. You'll need a spacesuit too, of course, atomic blue with jewels. This power gem will speed your ship across the starry sky. It only lasts till midnight. After that, your ship won't fly. Oh, thank you, Cinderella said. She quickly fixed the rocket, then tucked the sonic socket wrench inside her spacesuit pocket. She zoomed past stars and nebulas and parked beside a moon. The space parade was glorious. Each starship made her swoon. At last the royal ship approached. Her heart was filled with yearning. The ship of Cinderella's dreams, but heavens, what was burning? The prince's spaceship jerked and hissed and spewed a cloud of grit. The prince hopped out. Oh, bless, what now? My chief mechanic quit. But Interstellar Cinderella knew just what to do. She zip-zapped with her socket wrench. The ship was good as new. The prince invited her aboard. Last stop, Galactic Hall. He said, I hope you'll join me for the gravity-free ball. They talked for hours of rocket ships. The time went whizzing by. Then Cinderella saw the clock. Oh my, I have to fly. But wait, the prince called out after her. Please tell me how to find. The girl was gone, but she had left her socket wrench behind. The prince sent a transmission to the farthest edge of space. I'll search the cosmos for her. How I wish I'd seen her face. The prince's ship, Grisella screeched. Her sister squealed in fear. The prince won't marry one of us if Cinderella's here. Their mother said, don't worry, he won't find her in this house. I've trapped her in the attic with that useless robot mouse. The prince's cargo door revealed a broken craft within. The girl I seek can fix a ship, so who would like to begin? He gave the sonic socket wrench to one, then to the other. At last they couldn't fix the ship, and neither could their mother. Cinderella struggled, but the space rope held her tight, till Murgatroyd's robotic teeth cut through it with one bite. The ship is leaving. Wait! What's this? She made a few repairs, then strapped a rusty jetpack on and blasted through the air. She landed right beside the prince. "The wretch is mine," she cried. She quickly fixed the alien ship. The prince said, "Be my bride." She thought this over carefully. Her family watched in panic. "I'm far too young for marriage, but I'll be your chief mechanic." And amid her fleet of sparkling ships and friends both old and new, a joyful Cinderella cried, "My star's dreams do come true." So Interstellar Cinderella did get to be a chief mechanic because she studied to do it. Wasn't that amazing? Let's go ahead and do a little rhyme on my flannel board now. This is about 4 stars. So let's count them out. Here we go. 1, 2, 3, 4. 4 little stars winking at me. 1 shot off, and now we have 3. Let's count them. 1, 2, 3. 3 little stars with not much to do. 1 shot off, and now we have 2. 1, 2. 2 little stars were afraid of the sun. 1 shot off, and now we have 1. 1. 1 little star all alone is not fun. It shot off, and now we have none. And another word for none is 0. I think we can share a couple more of those jokes from our book here, Space Jokes. Here we go. Which astronaut goes into space the most? Sir Launch-a-Lot. And how do you know when the moon isn't hungry? When it's a full moon. That makes a lot of sense, doesn't it? All right, I'm going to share another story with you now. This is with permission from Random House. It's the Outer Space Bedtime Race, written by Rob Sanders, illustrated by Brian Wong. All right, here we go. And it is the Outer Space Bedtime Race. Good night, the children call while spinning on their earthly ball. They put their covers way up tight and turn off every bedside light. Tucked safely in their comfy beds, they're not the only sleepy heads. In outer space, it's bedtime too. The aliens need their sleep too. Those aliens zip around the sun. The time for racing has begun. The planets line up in a row. Now, ready, set, and blast off, go! In Mercury, kids land rocket ships. They hurry to their nightly dips. They glide along on rocky paths and steamy craters, bubble baths. Inside sleep chambers warm and snug, they squeeze together in a hug. Click, clack, go all the chamber lids. It's best bedtime for the Mercury kids. On Venus, time goes on and on. It seems like days and days till dawn. Kids shimmy into deep sleep suits and rubberized compression boots. They sip on warm galactic goop and slurp the slime chunks scoop by scoop. As satellites go whizzing by, loud snores from Venus fill the sky. The Martians scrub and wash and clean, and soon their skin is gleaming green. They rise and spit with Martian flair, then comb their tangled star-filled hair. They boing and bounce and giant springs, and land inside red hammock swings. The Martian parents softly hum when slumber time on Mars has come. To fall asleep in Jupiter, the kids count moons till their eyes blur. They use 12 fingers and 6 toes till finally they start to doze. The rings of Saturn circle round as Saturn kids at last bed down. They rest their heads on clouds of fluff. Get this, they all sleep in the bath. Uranus is a gassy place. They sleep with masks stuck to their face. Before lights out with beaks and books, they curl up inside cozy nooks. Since Neptune swarms with icy clouds, the Neptunites must sleep in crowds. Just as the clock strikes 59, those snoozes cross the finish line. The Pluto kids sleep on their feet, lined up together nice and neat. For Pluto is so very small, it's not a planet after all. The aliens are now asleep out in the cosmos dark and deep. They end their nightly bedtime race as planets spin through outer space. Far from the starry Milky Way, where asteroids zigzag and sway past comets and shooting stars, and all the way to where you are, the outer space bedtime race has now returned to our home base. With all the aliens in bed, it's now your turn, you sleepy heads. And that is the outer space bedtime race. Let's go ahead and do one more rhyme on my board. This is 5 little rockets. So let's go ahead and count them out. 1, 2, 3, 4, and 5. Here we go. 5 little rockets are ready to zoom. The first one said there's not enough room. It starts its engine, it's ready to fly. It looks at the others and waves goodbye. Zoom! Let's see how many we have left. 1, 2, 3, 4. 4 little rockets are ready to zoom. The second one said there's not enough room. It starts its engine, it's ready to fly. It looks at the others and waves goodbye. Zoom! And now we have 1, 2, 3. 3 little rockets are ready to zoom. The third one said there's not enough room. It starts its engine, it's ready to fly. It waves to the others and waves goodbye. Zoom! Now we have 2 left. 1, 2. 2 little rockets are ready to zoom. The fourth one said there's not enough room. It starts its engine, it's ready to fly. It looks to the others and waves goodbye. Zoom! Now there's only 1 rocket left. 1 little rocket is ready to zoom. The last one said, there's so much room. It starts its engine, it's ready to fly. It looks to the others and waves goodbye. Zoom! And now we have 0 left. No more rockets ready to zoom. And I'm going to finish off our story time with 2 more jokes. All right, here we go. What does the runner-up in the Miss Galaxy contest receive? A constellation prize. And finally, what do you call a spaceship that drips water? A crying saucer. Thank you so much for joining me in our outer space story time. And now I will send it over to Eldo.
Thanks, Maria. See you later. Those jokes were really funny. Still laughing about the constellation one. Now we're going to take a trip to a little village where Miss Jessica is going to teach us a little bit about how you can make at home a solar oven.
Hi everyone, my name is Jessica and we're here at the Little Village Branch, and today we're going to explore the sun's solar power through a solar powered oven that we'll be making with a pizza box, or if you have a cardboard box laying around in your house, we can use that too. So next time you eat pizza, don't throw away the box because you can use it to warm up that last slice or make s'mores outside. You can use any cardboard box you have in the house. You'll just have to change around some of the stuff. So we're going to explore the sun. And did you know the temperature at the center of the sun is 27 million degrees Fahrenheit? And the surface of the sun is 10,000 degrees Fahrenheit. So just think about the hottest day you've ever been through and multiply that probably by 1,000,000 times. So the oven we'll be making won't necessarily use the heat from the sun, but we're using the sun's ray to heat our food. We're converting solar energy into electricity, which is used for power. So for the oven to work properly, it needs to have 3 components. Aluminum foil, which is going to help reflect the sun's rays onto the box. Black construction paper or any dark paper that you have around the house. And this is going to help absorb the heat and trap it in the box. And then plastic wrap. And the plastic wrap is going to help contain the heat in the box. So let's talk about what materials we're going to use. So the materials we'll be using today are going to be, if you have a leftover pizza box, or if you have any other cardboard box, you kind of work around what you have. So just remember kind of the setup that we have for this. And as long as you have your 3 main components to keep everything warm inside the box, it should work or even work better. So you'll need a ruler, something to write with, a box cutter or scissors, saran wrap or cling wrap or plastic wrap, aluminum foil, black paper, any kind of tape you have, and then sticks, or you can even use the same ruler if you don't have sticks or straw laying around. So the first thing we're gonna do is we're gonna wanna measure about 1 inch from each side of the box. So you're just gonna go ahead and use your pencil or your pen or your marker and draw those lines going around the box. So mine is a little weird shaped. It's not really a squared. So I'm gonna have to go around the edge of the box and kind of curve it. If you have a squared pizza box, it'll be way easier because you'll only have to do the 4 lines of the box. And then the last line. And you're going to use your box cutter. If you have a box cutter, please let your adult help with it. If you don't have a box cutter, you can always use scissors. You can just start by kind of punching in one side of the box and then cut across. If you have a box cutter, it's way easier, but remember, use an adult so that they can cut it for you or they can help you cut it. And we're just going to go ahead and we're going to cut the 3 sides of the box. And when you cut, you never want to cut towards your hand. You always want to cut out and never have your fingers in the way of the blade. And we're going to leave this last side. We're not going to cut it, but we're going to fold it. So you're going to open up the box. And we kind of made like a new lid for it. So we're just going to go ahead and bend that last piece that we drew the line on. And we're making this new flap for the box. So this is where the aluminum foil is going to go. So you're going to take a piece of aluminum foil and we want to wrap the whole thing. So if you don't have tape, it's fine. You can wrap your aluminum foil and just wrap it down so it holds in place. If you have tape, it'll be easier. And you're going to put a piece of aluminum foil and you're just going to tape it down on the other side so it can stay in place. And you're going to keep going around until you cover the entire lid of your box. Okay, so we covered the entire lid with aluminum foil. I use tape just to hold it down secure. If you don't have tape, you can wrap it around the edges so it's all set to go. Our next step is to cover the box where we cut it out with plastic wrap because we want it to stay warm inside the oven. So we're gonna open up the box. And what we're going to do is we're going to tape plastic wrap onto the inside. And we want to make this nice and tight so that no air is coming out of the box and that we're keeping all the warmth inside the box. And after we tape the piece to the inside of the box, we're going to tape another piece on the outside of the lid and keep this side warm too. So what we did is we put plastic wrap on this side, and I used tape to hold it down. And we opened the lid and we put a layer of plastic wrap in the inside, and we also taped it down. And it kind of makes like this window. And remember, the plastic wrap is what's gonna keep the heat inside the box when it's closed. So we wanna make sure that no heat is coming out. So we really wanna press it down or tape it down so that this window kind of holds everything in the oven. And then on the inside, we're gonna add some insulation. So if you just wanna take some more aluminum foil, we're just gonna lay it down on the side and cover the edges. And just make sure you have some good amount there. And what we're doing this for is we're adding some insulation inside the box. So the more heat that stays in there, the faster it goes. And then what we're gonna do to top that off is we're gonna add some black construction paper. So the black paper is gonna absorb the heat. So we wanna keep this in here. So as the window's closed, the sun's gonna reflect down onto the box. The plastic wrap is gonna keep that heat inside. The black paper is gonna absorb the heat, and the aluminum foil is gonna help keep all the other edges nice and warm with the insulation. So let's go outside and try it out. I put cracker and chocolate for s'more. We're gonna close it up. And we're gonna prop open the lid. So you kind of wanna play with the sun's reflection and see where it's being reflected onto the plate the best. And what we're gonna do is, if you have the ruler, the stick, or a straw, you're gonna figure out what's the best height that helps reflect onto the plate. So right now that's a little bit later in the day. The sun's not as hot and not as high. So I think my best bet is gonna be my stick. So I'm gonna make sure everything's closed right. I'm gonna kind of point it down so it reflects straight onto the chocolate. And I'm gonna place my stick on the lid so that it stays open. And we're gonna leave this for about 10 minutes and check back on it. Today it's about 80 degrees, so we'll see how long it takes to warm it up. So I ended up putting a little piece of tape on our stick just to help it a little bit. And we've been out here for about 5 minutes on like an 80-degree day. And we're just checking in. And it looks like our chocolate is already melted down. So you can see it kind of starting to drip over. The longer you wait, the more melted it'll be, or the hotter the day is, the faster it'll melt. And you can try experimenting with bigger boxes or with different shaped boxes and different amounts of aluminum. You just always want to make sure that it stays closed all the way. Remember, this is a great way to save energy at home so that you're not using the microwave or the oven on a super hot day. You can just throw your stuff outside and warm up food. And thank you for joining us today.
Awesome. Thank you, Jessica. And thank you, everyone, for watching. Remember to look out for the recording of our special astronomer program later today. We'll be putting that up on YouTube. This is my last virtual second Saturday. And I just want to say thank you for everyone for watching over the past couple months. Thanks to my mom for always tuning in. And thanks to the Thomas Hughes staff, everyone in Children's Services. It's been a really wonderful ride. And I hope to see everyone soon. But don't forget to check out the local astronomer Joe Guzman program later today on YouTube. I'm going to go get ready for the Zoom program that's starting in about 1 minute. So thank you, everyone. Take care, and I will see you around.
Rocket says look up. Rocket dreams of becoming an astronaut, which means she's always got her eyes on the skies. Especially tonight, there's going to be a meteor shower. Can Rocket get her neighbors and her phone-obsessed big brother Jamal to look up and appreciate the beauty of the skies? Stella's stellar hair. When an extra special event calls for an extra special hairstyle, what's a girl to do? Jump on her hoverboard and set out on an extraterrestrial adventure in search of a new do, of course. Science fiction meets style and self-empowerment in this out-of-this-world picture book. Oh, and don't miss the back matter. Author-illustrator Yesenia Moises shares information about the different planets and how the atmosphere influences each of Stella's hairstyle choices. Feeling drowsy? Take the stars into your dreams with Child of the Universe. The iron in your blood, the calcium in your bones are made up of stars that lived long ago, writes astrophysicist Ray Jayawardena in this lyrical cosmic bedtime book. Drift off to sleep with dreams of distant stars and galaxies twinkling in your head. Or, if you're seeking a nonfiction book with lots of cool and real photographs of what it's like to be an astronaut, check out Mission to Space and visit the International Space Station with the author, real-life astronaut John Harrington, who is Chickasaw and the first Native American astronaut. Learn how he trained for his mission and join him in a spacewalk over 200 miles above Earth. And for kids ages 8 and up, here are a few more out-of-this-world books for you to check out. Dragon Pearl, How We Got to the Moon, The Lion of Mars, Hidden Figures, the Young Readers Edition, Smithsonian Maker Lab's 28 Super Cool Projects, Countdown 2,979 Days to the Moon, Voyager's Greatest Hits, the Epic Trek to Interstellar Space, and Chasing Space, the Young Readers Edition.
Hello, and welcome to our very special Second Saturday program featuring the Chicago astronomer, Mr. Joe Guzman, who's been doing some wonderful work with After School Matters and is a proud space ambassador. Now, this program was made possible thanks to the Chicago Public Library Foundation. I just wanted to thank them, and I wanted to thank all you for joining us today. I'm really excited. I love everything space related. See, I have a bunch of little rockets and little space toys hanging around my cubicle right now. But without further ado, Mr. Joe Guzman is going to take us on a trip around the solar system and also just show us a few very cool things. So, Mr. Joe Guzman, go ahead and take it away.
Thank you, sir. Aldo, I see a NASA shirt underneath your look at that. Look at that. It's lovely. We love it. We love NASA, right? Beautiful. Hey guys, welcome. Welcome to this beautiful Saturday afternoon. We're going to talk about the planets. A little bit about me. I'm an astronomer. I'm the astronomer for the Chicago Park District. I set up telescopes throughout the city so nice people like you can look through telescopes and look at the planets, stars, galaxies, the moon, the sun, and we have good conversations about this. And, we always talk about aliens, right? So it always comes down to life out there in the solar system. There's so much to talk about in the topic of space and astronomy. We can talk about galaxies or binary stars or space travel, even the creation of the universe. That's such a big topic to talk about. How did the universe get created? And where are we right now? That's called cosmology. We talk about this in my After School Matters classes a lot with teenagers, high school age kids. And hopefully one day I'll have you guys in my class and we can really indulge and talk about all things space and astronomy. Here are the ground rules. If you have a question, a comment, an observation, use that hand ability right there and just ask your questions. Even if I'm in the middle of a sentence, I want to hear from you. I want to know what your thoughts are. I want to know what you're thinking, any questions that you may have. If you want to keep your cameras on, beautiful, because I want to see you. I want to hear you. I want you to see me. And this is a fluid discussion back and forth. It is not a one-way lecture, just me yapping and talking and boring you. No, I want to know what you guys are thinking about. So we can answer questions and have a really deep discussion. Let me ask a question first. Let me see. Marianne, I see. Hi, Marianne. How are you? There she is. You have a favorite planet?
Hello.
Hi. Do you have a favorite
yes,
planet?
my favorite planet. Yeah, my favorite planet is Jupiter.
Why is it Jupiter?
For me is like I really am a big fan of like gas planets,
Mm-hmm.
and I really like how it has all the colors, like different shades of each color.
Oh, that's a great planet. Jupiter is the king of the planets, the biggest planet of all. And as a matter of fact, you can put all the planets from Mercury. Yeah, we're going to talk about Pluto too, all the way to Pluto inside of Jupiter and still have room to spare. So that's a beautiful selection right there, Marianne. Let me ask Lucia. Hi, Lucia. Hi, do you have a favorite planet?
My favorite planet is Pluto because it's tiny and I like tiny things.
She loves the tiny planets. Lucia, right now, the astronomical community says that Pluto is not a planet, but a dwarf planet. Personally, Lucia, I think Pluto is still a planet. I'm always fighting for little Pluto. So, Lucia, what do you think? Do you think Pluto is a full planet or dwarf planet?
A dwarf planet.
Okay. Can you tell me why?
Maybe because it was big once and then it became tiny.
That's a good theory right there. We'll talk about little Pluto when we go through all of the planets. Thank you, Lucia. Alex, hi, Alex. Alex, hi. Can you hear me? Uh-oh, I don't know if Alex can hear me, but let's go on to Eab. Hi, Eab. EAB. Can you hear me? I see you. Eab, do you have a favorite planet?
Yeah, I do.
Which is your planet?
Mars.
Oh, Mars. That is an interesting planet. Tell me why you like Mars.
Because it may have alien creatures and it's called the red planet, and I want to know why it's red.
Oh, that is a fantastic question. We're going to talk about that. We're going to go visit Mars when we take our tour of the solar system. And there is a specific reason why Mars is red. And we'll talk
and also
about
because a lot of other planets are red.
Well, like what? Which ones?
Mercury.
Mm-hmm.
Venus also kind of looks reddish.
Venus is very special. We're going to talk about Venus. That's the hottest planet in the entire solar system. And we're going to talk about why. Why is that? And it's not even the closest one, but it's so hot. Okay. All right. Let me ask one more. Amanda and Lily Beth. Hi. Hi, girls. I see you. Can you hear me? Hi. Do you have a favorite planet?
My favorite planet is Earth.
Oh, I love that planet. Tell me why you love Earth.
It's because we live on that planet.
Yeah, right. I do apologize for messing up the Earth, and I hope you guys fix it. So take good care of our planet. Take care of her waters, her atmosphere, her land, and she'll treat you nice. All right, let me bring up this app, and then we're gonna start. Hang on, guys. I'm gonna move this over to my other screen so I can see you. If it will let me, I hope it'll let me. Hang on, guys. Uh-oh, see, technical issues. Why am I not getting this? Okay, guys, here and here. All right. Now, I can't see you when I do this. I'm going to try. And here, I'm going to close this out, guys, because I want this to be just right for all of us. I'm going to restart this. And here we go. I'm going to move that over here, bring this back up. And we're going to go from the sun all the way to Pluto, and then we're going to come back to Mars, because Mars is very, very special. A lot to talk about. It's the only planet totally inhabited by robots right now. And there's a good mission called the Perseverance mission. Oh, Adrian's coming in. Excellent. and doing fantastic science. So here we go. Here it comes. Can I move this over? I hope so. Come on, please let me move it over. Oh well, it's not letting me move over. Okay, guys. Well, we're gonna do it this way. Ask questions at any time, guys. Let me hear you because I can't see you. Okay. And all right. And what I need to do is see this. All right, Mr. Aldo, can you see my my app?
Not right now. Just seeing you right now.
Well, that's not bad. All right, let me see what we got. Here, let me see. Can you see?
Oh, there it is.
All right, we got the planet Jupiter. Now let's go. And that's one of our guys' favorite planet. Okay, now it's working beautifully. I got my app right in front of me. I got you beautiful guys right over here. We're gonna get started. All right, what is this? What are we looking at right here? Adrian, I see you, Adrian. Hi.
It's a sun.
It's a sun. What is the sun? Can you tell me?
It is a star.
Oh man, you're so smart. It is a star. Adrian, can you tell me what the sun is made out of?
Hydrogen and helium.
Oh, hey, you need to be in my class, Adrian. You're so smart. Adrian's right, guys. Stars are made mostly of hydrogen. And what we are looking at when we look at the sun is the outer atmosphere of the sun. And it's mostly gas. You have hydrogen and you have helium, which is a little heavier. And the interaction between hydrogen and helium, when they fuse together, creates energy. Matter is never wasted. It's always converted into energy. So that's what all stars are doing. They're converting one element to another element. And when they do that, you get some beautiful radiational heat and warmth. And that's what makes Earth very pleasant to live on. And yeah, it's one of my favorite planets too. Now, if you look, Mr. Aldo, can you see my mouse move around the screen?
Yes, and
Thank you, sir.
We also have a question. I think Rigev and Giva are raising their hands. If you guys want to unmute yourself.
I don't see that, but Aldo, if you would let me know.
Well, is that the sun in 2029?
This is an app that I can control the time. And here is the sun right now in 2021. But once we get it to rotate and to move, then time moves on. And so we can go anywhere. We can go in the future. We can go in the past, anytime we want. Mr. Aldo, who has the next question?
I think that was it. Yes. No one else has their answers.
All right, guys, keep asking those questions. I love it. Around the side over here, you see some glowing going on. What's happening is that when the radiation is formed at the center of the sun, it takes literally thousands of years for these atoms to start to find its way up and away from the sun. And once it does that, it goes at the speed of light, which is pretty fast. You know, light travels at 182,282 miles per second. That's really, really fast, the fastest thing that we know. But even at that speed, the light that we see from the sun that shines on our hands and our faces takes 8.5
minutes to reach Earth.
One more time?
It takes 8 minutes to reach Earth.
Oh, Shub. How do you pronounce your first name? Shub?
Yeah.
Shub, you're so smart. 8 minutes and a half and 30 more seconds. Why? Shub, why does it take so long?
Because the sun is like millions of miles away.
It is millions of miles of it. Do you know how many millions of miles, Shub?
I think about 92 million.
Oh, you're so close. I love it. 93 million miles away, Shu. That's very good. That's excellent. I'm so proud of you on that answer. And yeah, even at the speed of light, 93 million miles, and it takes 8.5 minutes for that light to reach us. Can you imagine the other stars that we see billions of light years away? How long that takes? It takes a long, long time. And so let's go. Yeah, sure. Thank you. I love that answer. Over here, let's get a little closer to the sun, and let's move it over. Here we can see some radiation coming off our closest star, 93 million miles away. And if you notice on the edges, we see some flares. Well, we call these prominences. And what's happening is inside the sun is an electric field, an electromagnetic field. And every once in a while, the tops spin faster than the equator. So it's a gas body. It's not a solid body like the Earth is. And once it spins at different rates, the magnetic field gets pulled and tugged and manipulated, and every once in a while they break and they make this arc. It wants to leave, but the gravity in the sun is so strong that it pulls it right back down, and that's why we got these prominences here along the edge of the sun. It takes up something called plasma away from the sun. And all plasma is electrons without their nucleus, free electrons, because it's really hot on the suns, and then electrons don't like heat a lot. They don't like to be hot, and they want to escape. And so when the electromagnetic field pulls away, it takes all this plasma along with it, and the gravity is so strong it pulls it right back down, and then you got these beautiful arcs along the sun. There's some today. I took a look at the sun earlier today, and we got some prominences going on. In reality, guys, the sun is not yellow; it is white. We are in orbit around a white star. It's yellow because it looks prettier in the apse, and that's the star of Superman, right? But without our sun, we would not be here, and the sun has a good long life left. So we got a good 3 to 4 billion years left. Let's go, guys, to the first planet, Mercury. Can anybody tell me about Mercury? Any idea? Any thoughts? Over here, Ehab, what do you got? Ehab, did you have a comment? Okay, we'll continue. Mercury is a little teeny tiny planet. It's not big at all. It's a rocky planet. It's called a terrestrial type of planet. Very little thin atmosphere, barely nothing at all. And it's really hot. I would not like to be on Mercury at all, because it doesn't have an atmosphere. The light side of Mercury is really hot, past the point of boiling. On the darker side of Mercury, it's freezing, below 32 degrees, way below 32 degrees. And the reason that it's extreme on one side and extreme on the other side in temperature is that there's no atmosphere to move the heat around the planet like we do here on the Earth. And so one side is really, really hot, and the other side is really, really, really cold. Really a bad place to be. But Mercury has been bombarded by asteroids and comets and meteors. As you see along Mercury, it has a lot of craters. Some craters left ridges when it impacted the planet. And yeah, scientists and astronomers think that there was never really any life here on the planet Mercury. It's just too close to the sun. It's about 35 million miles away from the sun. We are at 93, and little old Mercury is at 35. Any questions on Mercury? Well, we have this little teeny tiny. Yes, Ahab. Yes, sir. Go ahead. You got your hand up. Go ahead.
At nighttime, I'm pretty on the dark side of Mercury. I'm pretty sure it's maybe a little colder than Saturn's temperature because I read it in a book.
It's true. And with no atmosphere, the skies are always black. There is no blue skies on Mercury. And you'll be very cold. You need a heavy, heavy jacket and big, heavy boots if you want to be on Mercury. Then when you go on the bright side, you got to take all that off and go in your shorts and gym shoes. So it's not a too pleasant place to be. Amanda, did you have a question?
No, but I actually drew something about on the solar system.
Mm-hmm. Oh, that's cool. And look at the pretty colors on it. And the sun is yellow. And we got, wait, hold on. Let me count. 1, 2, 3, 4, 5, 6, 7. You got 9 planets. Good for you. You got included Pluto inside with it. I love it. Excellent, Amanda. And then you can follow along as we go through the planets on our solar system. Fantastic. Any other questions on Mercury or comments or observations that you may have? Okay. Here we go to the second planet, which is what? Hey, Alex, can you hear me? Hi, Alex. Alex, what's the next planet coming up?
Okay.
Here we go. One more time.
I think it's Venus or something like that.
Alex, you are correct. 100% correct. It is Venus coming up. Now let's zoom in directly into Venus. Here is Venus. Let's zoom out a little bit. Alex, since I have you, can you tell me about Venus? What do you see on this planet?
Venus is a very hot planet, not hot as the sun, and is very dusty in that planet.
You are right. You're 100% correct. Let me go around. Marianne, can you tell me something else about the planet Venus?
One thing I know about Venus is that I know it's also very hot, but it's also very hot because I think it was because it had a very thick atmosphere or something. So that all the heat is trapped inside. So that's why it's very hot.
Oh, Marianne, you got to be part of my class when you get older. I want you to be one of my students. You are 100% correct. Let's go in a little closer to Venus. On the planet Venus, it is completely covered. I mean, 100% covered with clouds. There aren't any sky. If you were on the surface of Venus, you're looking up, you see nothing but clouds all around you. And the surface is kind of like orangey yellow. So everything would be yellow in your surrounding environment. As a result, as Marianne and Alex had mentioned, it's hot. It's really hot. It's hotter than today here on the planet Venus. Although it's the second planet away from the sun, it's hotter than Mercury. And it's because of those clouds. The clouds are made out of methane and they're kind of acidic. It's really a nasty place to be in. It's not, you couldn't breathe in the atmosphere. When the radiation from the sun hits the clouds, it goes through, just like it does here on the Earth, bounces off the ground, and it wants to leave into space like it does on the Earth. But these clouds are stopping that radiation from going up into the space. And so what's happening, it's trapping all of this heat inside the planet Venus. And the temperatures are so hot that it can melt lead. It can melt metal. There were 2 probes, 2 spaceships that went to land on Venus, and they were Russian. They were called the Veneras in the 1960s, way back in the 1960s. They landed, they took a few photographs, and they all melted away. That's how hot it was on Venus. And it's poisonous gas. There's some lava flows. There's volcanoes on Venus. It's really a uncomfortable planet to be on here. Let me, Lucia, can you tell me anything else about Venus? Maybe I missed something. Shub, I'll be right with you. Let me see if Lucia has something to say. Yeah, no. Okay, Shub. Yes, sir.
Venus is Earth's poisonous.
One more time, Shub. I didn't get all that. Repeat that, please.
Venus is Earth's poisonous.
Go ahead. Continue.
It's poison. Venus is Earth's mostly poisonous.
You know what we can do too is we can look inside of Venus. And let's open her up. And this is what it is allegedly inside the planet. Now, of course, we cannot open up a planet, right? But educated guesses is that this is how the inside of Venus looks. It has a very, very hot molten core in there. And the atmosphere is really up here. It's thin in comparison to the whole planet. But all that heat from the inside and the heat from the outside really makes Venus very, very, very hot. And the funny thing about Venus is that its day is longer than its year. I'll repeat that. It turns on its axis very slow, and it doesn't make a complete turn around the sun. The rotation just doesn't match. You know, for us, it takes 24 hours for the Earth to rotate, right, on its axis like this, 24 hours. But Venus takes a whole year to make one rotation on its axis. And it also does it backwards. All the other planets go this way. Venus turns that way. Don't know why. There's some theories out there on maybe Venus was a captured comet long, long ago and settled into its orbit. But, you know, it's speculation. Nobody really, really knows. So Venus is a very odd planet in heat and in motion and where it's at. If I were an astronaut, I don't think I'd like to go to Venus. But let's go to the next one.
Did you have a question, Iab or
Yeah,
Amanda?
yes, sir.
Go ahead.
I also know that Venus has an atmosphere strong enough to crush a submarine.
Mm-hmm. So true. The pressure with all that air above you, it's like going at the bottom of the ocean, would crush you down. So that's another reason not to go to Venus. Iab, you're so smart. That's so true. Planet
Amanda,
Earth.
Did you have a question, Amanda, before we start on Earth?
Yes, Amanda.
I wanted to say something about the Earth.
Yeah.
For mythology, Earth fell in love with Uranus.
Oh, I love it. There's a lot of mythology in astronomy. You know, Jupiter being king of the planets and Saturn being feminine. And when we get to Jupiter, I'm going to tell you a story on why we are not almost here. And it's because Jupiter's fault. You're right, Amanda. Fantastic on mythology. Planet Earth, fantastic planet. We have a lot of water. We have land to live on. It's temperate. You know, North Pole is kind of cold. South Pole is kind of cold. But overall, we are in what they call the Goldilocks zone. Okay, Adrian wants to come in. And it means, you know, not too hot, not too cold. It's just right. And as a result, we thrive here on Earth. Mars is also in the Goldilocks zone. We're going to go to that one next. We'll go briefly and we'll go to the rest of the planets and we'll come back to Mars. We have a lot to talk about on Mars as well. If you notice here on Earth, at the top, right here, is a green circle. Does anybody know what this green circle is on top of the Earth? Well, Iab. Now it's Elliot and William. But go ahead.
the auroras, also known as the northern lights.
You guys are so smart. Why do we have northern lights? Elliot and William, why do we have northern lights? Why are they there?
I think it comes from the sun, maybe with something. I don't know.
Okay, that's a fantastic guess. Shub, what do you have?
Because when solar will we come from the sun and interact with the particle, which causes some light.
I want you to be my student too, Shub. You're so smart. Yeah, you're right. This is all solar related. This is all sun related. What happens is that the particles that come off the sun, the protons, hit the upper magnetic field of the Earth. You know, maybe you've seen pictures where you got a nice magnetic field surrounding the planet. When the electrons and the protons hit this magnetic field, they light up like a fluorescent light bulb. It's exactly the same process. And it all depends on what's in the atmosphere at that time. They could be green, they could be red, they could be pinkish. It all depends. And of course, green is the most common color of an aurora. And we have them in the North Pole and we have them on the South Pole. Same thing, negative and positive. And maybe you guys did this experiments in school where you got a magnet, you got a negative and a positive. Well, the Earth has negative and positive too. And if the energy from the sun is great, if a lot of stuff comes from the sun to hit the Earth, the auroras, the northern lights, sometimes go as far down as Chicago, even as far down as Texas down here. But it's got to be really, really strong. And you know, with the light pollution here in the city, it's kind of hard to see, but I have seen them here in the city in Chicago. And so any questions or any comments on the planet Earth, our favorite planet? Alex. Hi, Alex.
Dirt is actually the crust of Earth.
Continue. Elaborate.
And if you dig all the way down, there'll be a little bit of pieces of metal and a little bit of crust. And there'll be a city down, and it'll be the last chance to see the gold miners.
Let's examine that. Let's open the Earth up. And this is what scientists feel that the inside of the Earth looks like. We have a molten core and a mantle, and it's hot. You know, when you drill deep into the Earth, the heat starts to raise up. We have discussions, you know, can you go through the Earth? Can you make a tunnel that goes all the way through? Well, really, no. You know, it's not a physically possible thing to do. But it is hot in the middle. It's very, very hot. And the atmosphere of the Earth is really, really thin. In comparison to the planet Earth, the atmosphere of the Earth is really only as thick as a sheet of paper. It's only about 65, 80 miles thick. So we got to take care of this planet. And yeah, there we go. So let's close her back up. And we have a lot of water, a whole bunch of water. But there's some bodies out there in the solar system that has a lot more water than what we do here on the planet Earth. We're going to visit some of those right here. There was another question with Amanda. Hey, Amanda.
Every planet has layers like a jawbreaker.
Yeah, it does. All planets have layers like a jawbreaker. I never heard it put in that manner, but I may use that in my discussions. It's so true, Amanda. Especially the gas giants, because the higher gases, the lighter ones, hydrogen and helium and methane, as it gets heavier, you got layers going down. So yeah, you're so smart. Excellent. Elliot and William.
I want to know why Why it gets hotter the deeper we go in the earth.
Great.
And also, why is it hot down there?
Great question.
And where did the lava come from?
Well, they all match. All those questions are interrelated. When the solar system was formed billions of years ago, they were all made out of gases like hydrogen and helium and all the gases that we talked about. And then one atom collected to another atom. Two atoms collect one atom. Now you got three, and that went on for billions and billions of years. And then there's action, there's friction going on. And then the heavier metals, magnesium and calcium, and eventually iron. Iron always goes to the center of all bodies because it's the heaviest of the elements. So there's an iron core inside of the earth. As other lighter elements started to surround the heavier ones, it trapped the heat, almost like what Venus is doing right now, but in a different kind of scale. So it's really, really hot. And when you get really hot, the iron starts to melt, and the magnesium and all of these rocky materials, they are in a perpetual fluid state, like lava. There is lava in the center of the earth. And that's why it's so hot, because of the energy that, when you rub your hands together, you can feel the heat. Same thing's going on inside the earth. And we have tectonic plates that go under one and over, and mountains are created and volcanoes are formed. That's a good thing, because we want the earth to be alive and active and not just there doing nothing. And things move around, weather is beautiful, and we all of that to the early formation of the solar system, and that's why we are here, at least for now. I saw another question over here on Reg and Giva. Yes, sir.
Well, my name is Ragev, anyways. But
Regev.
why is there so many lights in America? And can you zoom in on them?
I sure can. Over here, and let's zoom in a little bit. Here is the United States. Here we are in Chicago, right here. These are all cities, and you can see highways that are lit up going to the west as well. As an astronomer, I like dark skies. I can see more stars, and it's hard for me to get away from all of this light pollution. Let's move out a little bit. And as daylight starts to come, you can see the lights start to go out, because we don't need the lights in the nighttime, only in the nighttime. And as you see, the United States is turning off their lights, and China and Japan are now turning on theirs. So it all depends on what time of day it is. And if you look in the middle of China, beautiful dark skies. I'd love to be in the middle of there. Or in the middle of Africa, dark skies. Yeah, you can see the whole bunch of things over there. Over here, Adrian. Yes, sir.
Oh, what is the difference, if you know, of blazons and quasars?
Oh man, that is a deep question. We were even going to talk about stars today, but a blazar is a very hot star, and that's why they call it blazing, because it's blazing, right? It's very hot for its size. Usually stars that are huge produce a lot of heat, but blazars are almost like the size of white dwarfs, and they're really tiny. Quasars are bright. They're not necessarily hot. They are hot, but not like a blazar is. But quasars are at the far ends of the universe, near the Big Bang era, 14.7 billion years ago. And they're like light posts. The scientists really don't know why they are there, but they're very bright in comparison to their size. So a blazar is hot, a quasar is bright.
Oh, I don't think you have that like a figure of a black hole.
Oh, now we want to go to black holes. I would love to talk about black holes, but we don't have time today. Maybe Mr. Aldo, we can arrange for another one. We can talk about black holes and cosmology and all of this good stuff.
Yes, for
Adrian,
sure.
You got some fantastic questions, man. I would love to answer all of these, but black holes are a mysterious animal out there. They're Einstein predicted it in the early 1919s, and the gravitational force of a black hole is intense. There's a black hole in the center of our galaxy. Some say there's even a black hole beyond the orbit of Pluto. And yeah, if you ever seen the movie Interstellar, that's a perfect description of what a black hole looks like. And only 2 years ago, we took a picture of a black hole, never before done, and it was done by a woman. And this is her job, and fantastic for her, and her colleagues. They finally took a picture of a black hole, and we've measured the gravity waves from two black holes crashing into each other, which is fantastic. It's called the LIGO. Two L's, one upside down and one straight up, and they measured the pressure of a gravity wave, which is really, really, really cool. Let's leave the Earth. Great questions, guys. I love it. Keep them
We
up.
have one more question. I
Yes.
think Nate, Zeke, and Ellie, did you want to ask a question? I see your hand is raised. Or did you type it in chat? Let's see. No.
That was just a mistake.
Okay, no problem.
Okay. All right, Nate, Zeke, and Ellie. Ask your questions, and everybody ask your question. I love them. I love the dialogue. I love the discussions that are going on. Here is Mars. Marianne, let me start with you. What can you tell me about Mars?
I know that it's usually called like the big red planet or spot because it has like it's red. It's like a planet that's like dirt, but the dirt is like red.
Yeah, it sure is. It sure is. Shub, what can you tell me about Mars?
It's like 1/3 of you'd weigh like 1/3 less on Mars because it's 1/3, only 1/3 the size of Mars.
I know exactly what you're saying, Shub. Here's the Earth. Mars is 1/4. We were very close. The size of the Earth. It's not even a full, not even half. It's 1/4 the size of our planet. But Mars was one time an alive planet. We're going to talk about that in a little bit. Any other observations on Mars? Can you tell me something more about the planet Mars? Elliot, you got some good questions. Can you tell me about Mars?
Well, I see it as two moons, Phobos and Deimos.
Do you know what Phobos and Deimos means?
No.
The Romans, and I'll get to Amanda in 1 second. The Romans named these moons of Mars, Phobos and Deimos, meaning terror and fear. And Mars is the god of war. And that's why, it's red and color of blood and all that kind of stuff. So it kind of all matches here. Regev, you have a question? Okay, let's go to Amanda.
But I don't see there I see Deimos.
Okay, yeah, it's around. We'll zoom into them because one of them is like a potato. It doesn't even look like a sphere. Amanda, you have your hand up, please.
There's 5 rovers on Mars.
There's a whole bunch of rovers on Mars. Yeah, you are correct. Mars is the only planet inhabited by robots. There are a bunch of robots right now from the U.S. and China. And there's even
Curiosity.
One more time, Amanda. I'm sorry.
One of them is called Curiosity.
Yeah, Curiosity is a favorite of a lot of planetary scientists, and it's still rolling around. It's still doing this thing. And the two ones before it, Spirit and Opportunity, they were only supposed to be there for 3 months, and it's 10 years later, and Opportunity is still going on. Spirit got caught in some sand, and its solar panels got covered by dust, and it stopped working. But right now we have 3, 4 with China robots roving around Mars. We're going to talk about that one if we have time to go to the end and come back to Mars. But let's talk about the geology of Mars here. It's red, right? You have made mention of that it certainly is the red planet. Even in the sky, when Mars is overhead, you can see the color red with your eye. You don't need a telescope or binoculars or anything. You can tell it's a red body. There's a process why it is red. Let me ask. Hey, Adrian, can you hear me?
Yes.
Yeah.
Adrian, if you leave a hammer out or something metal outside, what happens to that metal?
Oh yeah. If it would be raining, it would rust.
It would rust. That's exactly what's happening to Mars.
Yeah, Mars had rusted.
Yeah, it is. Mars is rusting away. That's why the Mars surface looks red. It's called iron oxide, and the heavy metals in the soil are oxidizing with Mars. So that tells us, number one, that there is oxygen on Mars. Number two, that there's water on Mars. And when you combine those things together with some metal, you get rust. And this is why Mars looks red. And Mars at one time was almost Earth-like. Let me stop this here and zoom in.
And scientists think that Mars has life. It has the basic chemicals that life needs. It needs some stuff.
Shub, you're onto it. That's why we're sending probes up there to Mars to look for signs of life. Because you got a lot of water on Mars. And 2, there is a oxygen atmosphere. It's mostly carbon dioxide, the stuff that we breathe out. And there's some nitrogen on Mars as well. And the skies on Mars are blue. Not as deep as here on the Earth, but they are blue. And there could be life on Mars right now, at least bacterial, under rocks or something. And that's what the rovers are looking for at this present time. If you look here, you could see there are clouds on Mars too, just like the Earth. Carbon dioxide, some water vapor as well on Mars. And they flow around the planet just like Mars. And Mars has weather. Mars has climate. Mars has seasons. At one time, it was very, very Earth-like. And I'm going to show you guys this, if I can get it around to this end over here. If you notice over here, you can see outlines. There used to be oceans on Mars. Oceans and rivers and lakes of flowing water, just like the Earth. There is evidence that it was a lot of water on Mars, and that's why these
Zoom into
probes.
the outlines.
One more time.
Can you zoom into the outlines?
I sure can, as best I can. Let's pick this one right here. Let's go into here. There we go. And you can see the coastline of what was once an inland lake or down here an ocean that was at one time around Mars. And this is almost like the island of Madagascar here on the Earth. And here was water at one time around. Different sediment deposits all around Mars. And there's something called spherules, little blue balls all around the planet. And these are only made in water. And we have tons of them here on the planet Earth. And on Mars, these rovers have found these little blue spherule balls. And that's evidence of water. Mars has polar ice caps, a big one on the north and a kind of tiny one at the bottom, right over here. In telescopes, we can see this quite easily. We can see these things move around. There are big sandstorms on Mars, huge sandstorms. Sometimes it covers the entire planet and we can't see anything on the surface. But the atmosphere is very, very thin. If you go on Mars, if you were an astronaut in 10 years and some of you guys become astronauts and you go there, you land, you can't take your helmet off because there's just not enough air to breathe. You'd be gasping for air. It's almost like being on top of Mount Everest, where you need oxygen to survive and to breathe. I want to show you guys before we leave Mars, if I can find it. I need this guy to rotate into the light. Here we go. Mars at one time was very, very active, just like the planet Earth is right now. And how we can tell that is because Mars at one time had volcanoes, active, huge volcanoes. And if you see here, you can see 1, 2, 3, and there are more volcanoes all around Mars. But these are in a line, if you notice. They're in a pattern. That tells us that the plate on the bottom was moving over a hot spot. And they're just like Hawaii is right now. And when you move this plate over a hot spot, a volcano starts to form. And then it keeps moving and another volcano starts to form. Well, Mars was doing this at one time. And if you look over here, this is a huge volcano. It's called Mons Olympus. This is the largest volcano in the solar system. It's way higher than Mount Everest, and its width is bigger than the state of Utah. So this is a monster volcano. At one time, it was spewing lava and ash, and here comes an ambulance passing my street, so I hope that didn't interrupt me. And you see clouds still going around the planet. All right, it has passed. And there is photographs right now, guys, on some smoke coming out of this lower volcano. Scientists don't know if it's an active volcano or if it's just condensation from the planet's atmosphere, or maybe steam. Don't know. But Mars is well alive. And here, guys, is a canyon. This canyon is huge. It almost goes around the entire 1/4 side of the planet. It's way bigger than our own Grand Canyon. As a matter of fact, you could fit our Grand Canyon into a little side pocket over here. That's how big this Grand Canyon is. And this tells us that Mars' surface was being split and things were moving around and there was activity going on and oceans and a thick atmosphere. What happened to
has the biggest canyon in our solar system?
The biggest what, Shub?
Canyon in our solar system.
You're very smart. I'm glad on these questions. I forgot what I was going to say, but that's fantastic. Here, let me go into this just quickly. And here is one of the rovers, Opportunity. Great little machine. It's got solar panels, doing experiments. Can we get a little closer to on? There we go. It's got cameras. It's got a digger, digs into the soil. It's got a RAT, rock abrasion tool. And what that does is that it grinds rocks up to see what's in it and do an analysis on board. It's still going strong. Great little machine. Let's go back. The MRO, guys, the Mars Reconnaissance Orbiter, is orbiting Mars right now. Its main mission is to sniff the air of Mars. What kind of components, what kind of molecules are around Mars right now? And it's searching for evidence of life, too. There is a lot of carbon dioxide. There is a lot of methane around Mars. This spacecraft discovered that. And methane is a fingerprint of life. Whenever you have life around, be it humans, cows, insects, whatever it may be, bacteria, you have CO2, carbon dioxide, and there's a lot of it around the planet, and methane combined as well. So these are all evidence and pointers that show that Mars was once very much alive and maybe still wants to come back. This is the North Pole over here. way up here. Carbon dioxide ice over here, and some water as well. So let's go back out. Mr. Aldo, how are we doing on time?
So we're almost at 12:30. It's 12:27. We can go over like 5 minutes if that's okay with you.
That's fine with me. Yeah, I can go over two. I can go over 2 hours.
So at 12:35 we'll end, which is like 10 minutes away. But if anyone has to leave, we understand. But yeah, we'll stay on until 12:35. So we have about 8 minutes left.
All right, let's go to one of our students' favorite planets, Jupiter. Marianne, was this your planet, Jupiter?
Yeah,
Marianne, tell me about Jupiter.
it was my favorite.
And tell me, can you tell me more about the planet? You know what's going on there?
One thing I know is that it has like a storm, a big red storm
Mm-hmm.
right there. I think I see it.
Mm-hmm.
And I know it's made out of gas. It's the biggest gas planet.
It sure is. A lot of good points there, Marianne. Fantastic. I want you to sign up for my class when you get a little bit older. I would love to have you there. Let's zoom into the Great Red Spot, the GRS. This is a hurricane-like storm on the atmosphere of Jupiter. Galileo saw this GRS back in the 1600s with his crude telescope, had no idea what it was. And it's a low pressure system on Jupiter that has lasted hundreds and hundreds and hundreds of years. And it has faded from time to time and it's come back up. And when you look at Jupiter, when you see the brown, you are looking deep down inside of the cloud tops. And when you see the white part, you're looking at the tops of the cloud tops as well. These clouds are mostly made out of ammonia and methane. Really nasty stuff to breathe in. It's not pleasant. There is a core in there someplace. Let me zoom out of Jupiter, but it's mostly a gas giant. Let me open this up and we can show Marianne what the inside of Jupiter may look like. Speculation, we could never go inside of Jupiter because the pressure of all that atmosphere would crush us like a can. And so like going in under the ocean, same thing, all that pressure. Yeah, it's a huge planet. Let me get out of here and do that. Huge planet. You can put all the planets from Mercury all the way to Pluto, including Saturn, Uranus, and Neptune. And you can put them all inside of Jupiter and still have room to spare. That's how big Jupiter is. Jupiter almost became a star itself. It was so big that all it needed was just a little bit more in size, and the hydrogen would have ignited just like our star did, and we would have 2 suns in the sky. Or maybe we wouldn't be here to see it because now you got 2 energy sources in the solar system, and extra radiation and interference with formations, and don't know. That's speculation, but we would be a binary star system. These are called the equatorial bands, north and south. And Jupiter has about 68 natural satellites. We don't like to call them moons because there's only one moon, and that's our own. And that's a proper name. It's called moon, or Selene, or Luna, or whatever language you're in. But we prefer to call these bodies that orbit the planets natural satellites. Let me zoom out a little bit, and we can see the 4 major natural satellites of Jupiter. I want to go into Europa right now before we lose time. Europa is a ice-covered moon or natural satellite, totally covered in ice. And it's H2O, it's water. And if you go, how far can I go in? There we go. You see these little cracks. That means that this ice is moving. It's crackling. It's just like you see glaciers or ice in the North or South Pole. They're moving around. They're active. That means there's some heat underneath. And what happens when you melt ice? Well, you get water. And below this ice cap around Europa, are oceans and oceans and oceans of fresh H2O water. And I bet that would taste quite refreshing on a hot day like today. What NASA would like to do is to land a probe on the surface of Europa, drill a hole, and send a little submarine to see what's swimming underneath. There could be creatures down there, maybe bacterial or algae, or maybe even something more complicated like some sort of amphibian fish, or who knows what's down there. And maybe you guys will discover it and tell us what's happening there. Let's zoom out. In comparison to Europa is another natural satellite called Io. Now, if you notice, Io is really close to Jupiter than Europa is. And when we go into Io, it's almost like Venus. Io is being pulled and tugged and squeezed and manipulated between Jupiter's gravitational field and the sun. So this little poor body is just being like a ball of Play-Doh, being pulled and tugged. As a result, things are getting melted and lavafied. And Io completely turns itself inside out on a regular basis. And it has volcanoes, and it has lava, and it has a lot of sulfur. Sulfur is not too pleasant. And yeah, so in comparison to Europa, nice, cool, drinkable water. Io, a volcanic planet, almost like Venus. And in our solar system, it just goes on and on with all these stories, guys. I want to just show you one more planet, and then one of my favorite planets. And in the telescope, beautiful to look at, the planet Saturn. Saturn with her beautiful rings, same gas combination as Jupiter does. There's a lot of methane on Saturn. Blue is the fingerprint of methane. So here's methane on top, and more hydrogen and helium near the equatorial regions. And the rings of Saturn, although very, very beautiful, are only 30 feet thick. That's thin in the whole concept of the whole universe, only 30 feet. But they're so reflective that you can see them nicely in binoculars and telescopes. And I show the public and my students these rings often, and they're beautiful. And again, Saturn has a nice natural satellite system. Enceladus is similar to Europa in that it is another ice world. And underneath this ice is H2O, liquid water, just like in this bottle. I'd like to take a drink of that myself. There's some crater marks, which means that the action there is not as active as Europa. It's kind of slower. So when things hit it, they don't get eroded as fast as the other natural satellite does. Mr. Aldo, I think that is the tour of our system with the time allotted to me.
Yes, so many great questions. We weren't able to get through the whole solar system, but I'm so happy that you were able to be with us today. Before we go, I just want to
Thank you.
thank you.
You're welcome, guys.
Before we go, there was a kit where you can make your own rover that goes along with this program. If you haven't received it yet or reached out to me, please send me an email. We still have materials where you can make your own rover out of some of the stuff that we have. And it comes with a little astronaut, which is really cool. But yes, we want to thank Mr. Guzman. So we can all give him a round of applause. We really hope that you'll be able to join us again, because there was so many other questions that I'm sure kids had for you.
And applause to our students for all these great questions.
Yes, I was so impressed and amazed. You guys were great. Amanda, did you want to say anything else before we go?
Oh, actually, I was going to say something.
Sure.
I was going to say that there was this theory that I heard that we used to live in Mars, and that's why it's so it was so similar to Earth. But then we ended up destroying it, and so we moved on to Earth, and now it's happening again.
Oh, and I had something to say too. Saturn had 7 rings. Saturn.
It has a lot more than Saturn. It has thousands of rings. Miss Amanda, you are, that's that theory. that we are the Martians, that we left Mars and we came over here because we messed up that planet and we're messing up this one too. So that's a theory as well. I'd love to talk more about that. And there was a planet in between Mars and Jupiter as well called Tiamat, and that now is the asteroid belt. So yeah, we could talk about these theories at a later time.
Humans never lived. I don't think humans ever lived on Mars.
Okay, well, Shoop says no, he doesn't agree with that theory. And yeah, okay, let's explore. You know, maybe not, right? Maybe we just stayed here on the Earth, and this is where we're from. And this is the beauty of a dialogue of conversation and debate. So Shoop, when you become my student, let's debate about this more. I'd like to talk more about it. Guys, if you have any questions, just look for Chicago Astronomer online. All roads lead to me. I'll be happy to answer, and I would love to have you come out to my observation sessions with telescopes. Bring your families. It's always free. We're going to be at Horner Park on the 17th and West Lawn Park on the 19th, and I'm at the 606 on the 18th. So I'll be everywhere.
Awesome. Well, thank you. I'll send up a follow-up email to everyone with some of that information. But thank you. Have a great Saturday, and we'll see you next time.
Thank you, guys.
Take care.
Goodbye. Thank you.
See ya.